Alright, these are notes 3A. Today we'll be discussing how to graph and write piecewise functions, step functions, and we're going to start absolute value functions. Alright, so you should have your notes in front of you. As we go through the video, make sure you're completing the notes. If you have a question at any time, jot down your question so you'll remember to ask it in class. So first of all, what is a piecewise function? It's a function which is defined by multiple subfunctions, and each subfunction applying to a certain interval of the main function's domain. Alright, that might still seem pretty complicated, but here, let's look at an example of a piecewise function. So f of x, which is function notation, is another name for y. This is an example of a piecewise function. Notice it's in pieces. So as the domain restriction, that's your interval, is x is less than -2, you're going to graph -1/2 x plus 3. Domain changes to a different interval and you have a different graph. Here is a quadratic. And then finally the domain changes again, and this time we have another line, a horizontal line at -4. So a piecewise function just means that for each, or as our domain changes, we're going to have a different piece for our y. Alright, let's first start off by evaluating. So if we want f of 10, alright, so that means we're going to be looking at this first function here. This is the one we're going to be looking at. Alright, f of 10. F of 10 is another notation that's saying x is equal to 10. You want to find the y value. If x is equal to 10, what's the corresponding y value? Alright, now we should be only, because this is a function, we should be only getting one y value. So we have to look at our x and decide which piece are we going to use of our piecewise function. So since my x is 10, 10 is greater than 2, that's a true statement. That means I'm going to be using this piece of my function. So f of 10 is equal to -4. What you've done here is you've created a point on your graph. So 10, -4 is a point on our graph. Alright, let's look at g of -2. So that means this time x is -2. So where we plug in for x, where is -2 true? Well, -2 is not less than -5, but -2 is between -5 and 7. So that means we're going to be using that piece of the graph. So we're going to use x minus 2, and we're going to plug the -2 in for our x. So that means our corresponding y value is -4. Here again, we've made a point, -2, -4. That point would be on that function g of x. Alright, g of -6. Alright, take a moment. Decide which piece are we going to use. Piece 1, 2, or 3? Well, hopefully you said piece 1, because -6 is less than -5. So that means g of -6 is 3. So here again, another point on that graph would be -6, 3. Alright, number 4. If you want to try before I do it, pause your video for a moment and try the problem. Alright, which piece of the graph are we going to use? So -3, x is -3. So where is -3? We want to know where we got a true statement. So since -3 is less than -2, that means we're going to use the first piece of this graph. So I'm going to have -1/2 x plus 3. And we're going to plug -3 in for our x. Alright, do that math. We're going to get 3/2 plus 3, which equals to 9/2. 9/2, 4.5, 4.5, all acceptable answers. Okay, so that's evaluating. And we're going to use that as when we go to graph these. So first of all, let's look at it. We're going to look at how to graph a piecewise function. Alright, so we see that we're going to have 3 pieces to our graph. Alright, this kind of requires a little setup work. This is kind of like I said, you got to keep yourself all nice and organized. You don't want to get confused. So let's take each piece at a time. So we're going to graph that first piece. Alright, notice it's a line. So our x is less than 2, x less than 2, and we're going to graph x minus 3. Kind of a variation of your t-charts that I kind of use. Alright, x less than 2. That means there's an open circle at 2. So it's going to come all the way up to 2, but it's not going to touch it. But we have to get all those infinite numbers before 2, so that's why I'm going to start this at 2, but put an open circle. that's telling me, like I said, I can get all the way up to 2, but not quite get there. I can get 1.9999 to infinity, but I can't quite get to 2. You do not want to start this at 1 because you're going to create a gap in your graph, and that won't work. All right, less than 2. So let's get 3 points less than 2. So 1 and 0. Anything less than 2. All right, plug and chug. So 2 minus 3 is negative 1. 1 minus 3 is negative 2. And 0 minus 3 is negative 3. All right, let's graph those points. So at 2, negative 1, we're going to have an open circle. At 1, negative 2, it's closed because it's less than 2. The only thing that can be open is that very first point. Everything else is going to be closed. And then 0, negative 3. All right, we're less than, so we're going in this direction. You want to plot at least 3 points to make sure you haven't done any careless arithmetic. All right, let's do that second piece. All right, so x is equal to 2. So draw yourself another little t-chart. If x is 2, we only have one value for 2, y is 4. So all this is the point 2, 4. And because it's equal to, it's closed. You're never going to have a single point that's open. All right, let's do our final piece. So one more t-chart. Get yourself all set up. So x is greater than 2 this time, and we have negative x minus 2. So we're still going to start at 2, but it's open. But this time we want to go greater than 2. So say 3 and 4. All right, so plug and chug. We got the opposite of 2 minus 2, which is negative 4. The opposite of 3 minus 2, which is negative 5. And the opposite of 4 minus 2, which is negative 6. So at 2, negative 4, we're open again. At 3, negative 5, we're closed. And at 4, negative 6, we're closed. So this piece of the graph is going in that direction. So there's how we graph a piecewise. All right, notice it's still a function. All right, it's still a function because the vertical line passes. Because at that 2 value, there's only one y value. Okay, because these two are open. So that's why it's still a function. Now it's discontinuous. Where is it discontinuous? Well, at that 2. At x equals 2, it's discontinuous. All right, add your domain and range. It wasn't on your notes, so let's add that to it, domain and range. All right, notice our domain here, even though we have that discontinuity here at 2, we still cover all the x values. So that means our domain is all reals. So negative infinity to positive infinity. All right, how about our range? That's going to be a little bit more complicated. Okay, so let's look at our range. Well, we've got this value at 4, okay, and that's the only thing we have in the upper part of our graph. So here, we're at 4, all right, and we've got a jump in there, so we're going to put a union in there. We'll talk, ask me questions, class, if you have any. All right, so where does this thing pick back up? All right, so from here down, it's continuous, okay? But so we pick up at a y value of negative 1. It's open at negative 1, and it's going down to negative infinity. So I got my order backwards. Let's change that. So it's going to go from negative infinity to negative 1 is the rest of our domain. And it's open at negative 1. Okay, let's graph a couple more of these. All right, but notice this one. So notice our x's have a beginning and end for each of them, and our y values are only going to be horizontal lines. Because we've got they're only single values, 3, 4, 5, and 6. All right, so let's get an idea of how this goes. Let's look at that first piece. So we're going to graph between negative 4 and negative 2. So we're going to start it at negative 4. We're going to end it at negative 2. It's closed at 4, negative 4, and open at negative 2. Let's put another number in there, negative 3. So when x is between those values, y is going to be 3. So that means the y is going to be 3 each time. Alright, so at negative 4, 3, 1, 2, 3, 4, we're at positive 3, and we're closed. At negative 3, 3, and at negative 2, 3, we're open. So notice we have just like a little segment there. Alright, let's look at our next piece. You might notice a pattern here. So our next piece. This time x is between negative 2 and 0, and y is 4. So negative 2, 0, we're closed, we're open, negative 1 in between. Well, here again, our y values are always going to be 4. Alright, so at negative 2, 4, we're closed. At negative 1, 4, and at 0, 4, we're open. So there's another little segment. Alright, well, hopefully you've picked up that pattern, right? So we don't need to do the chart for the next two. So what is this thing going to start? It's going to start at this third piece here is what I'm working on at 0, 5, and it's closed. And it's going to end at 2, 5, and it's open. So there's another little segment. And then finally that last piece, it's going to start at 2, 6, and it's closed. And it's going to end at 4, 6, and it's open. Alright, so there's our function. Alright, so what does it look like? Alright, hopefully, like I said, it kind of looks like steps, right? Stairs. So this is called a step function. Okay, now notice all of our steps were the same length. They don't have to be. They can be vary in length. The whole idea of a step function is made up of horizontal segments to be a step function. Alright, where is this continuous? Well, it's continuous in lots of places, right? It's discontinuous at negative 2. It's discontinuous at 0. And it's discontinuous at positive 2. Alright, the domain of the step function. So the domain is our x. So our domain starts at negative 4. Our x starts at negative 4 and then continues until 4. Now look at our inequalities here. This is less than or equal to, which is closed, and this is less than, which is open. So that means our domain is going to be close bracket, negative 4 to 4, open bracket. And that's an interval notation. Now our range is different, a range of these individual points. So the range is going to be the set 3, 4, 5, and 6. Notice we have two pieces. They're both lines right now. We'll add more to it as we learn, more shapes to our piecewise functions. Okay, alright, so let's look at that first piece. So where x is greater than 1, we're going to graph 2 times x minus 1. Alright, so we're still going to start this thing at 1, but since it's greater than, it's going to be open. Alright, greater than, so we're going to go 2 and 3. Alright, let's find our corresponding y values. Plug in 1, you get 0. Plug in 2, you get 2. And finally plug in 3, and you get 4. Alright, so let's graph those pieces. So at 1, 0, we're open. At 2, 2, you're closed. And at 3, you're closed. 3, 4, you're closed. Alright, so let's try to hit the points better than I did. Alright, so there's the first piece of our function. Alright, let's graph that second piece. Give myself some room here to work. Alright, so what are we going to do? When x is less than or equal to 1, we're going to graph 2x minus 3. Alright, so we're still going to start this thing at 1, but we're closed now because it's less than or equal to. We want less than, so let's do 0 and negative 1. Alright, plug in 1. 2 times 1 minus 3 is negative 1. Plug in 0. We're going to get negative 3. And plug in negative 1. You're going to get negative 5. All right, let's graph those. So 1, -1 were closed, at 0, -3, and at -1, -5. There. So there's the second piece to our functions. All right, this is discontinuous at x equals 1. Here again, let's do domain and range. All right, domain should be all reals. Range, it's going to be a little bit harder. So let's do this piece first. It goes from -infinity all the way up to -1, and it's closed. Union picks back up at 0, it's open, and goes to +infinity. Alright, so there's our domain. Alright, we're going to do a couple now with reverse thinking. That means we're going to go backwards. We're going to give the function. We've got the graph, and we're going to go back and give the equation for the function. Alright, I usually like to work from these things from left to right, so I'm going to work on this piece first. So my piece I'm working on is going to start this line here. Because right now all we have to worry about is lines on this first lesson. Alright, notice where this thing turns. Alright, so here I'm looking at this piece, my x value, x is going to be less than or equal to 0. Alright, we want to know what is the equation of that line. Alright, what's the equation of the line? Let's see. So y equals m times x minus a point, x sub 0 plus y sub 0. Point slope form here. So a point on my graph. Or we could do, like say, y equals mx plus b. You got to get the equation of that line. So whatever method you want to use to get the equation of that line. All right, so we need to get the equation of that first line that I've highlighted in red. Okay, so let's talk about point slope form real quick. All right, like I said, that's fine. Like I said, you can get the line any way method you want. This is one option that you have. Okay, so here, what's our slope? You see, let's pick a point on our line to use for point slope form. Okay, it doesn't matter what point you pick, as long as it's on your line. So if you look at your slope here, you see it's -1. So x minus, all right, the coordinates of that point, that's x minus a -2 plus 2. All right, simplify that. You're going to distribute that. So we're going to go with negative x plus 2 plus 2, distribute my negative. So negative x minus 2 plus 2 is equal to -x. So the equation of that line, that piece of my line, is -x, or the opposite of x. All right, let's do the same thing to the other piece. So let's look at this. We're going to start here and go on. Okay, so let's find the equation of that. And like I said, point slope form works every time, so like I said, I want to pick another point. All right, now here, since I closed here at x is less than 0, my other side has to be open. Now you might ask yourself, which one has to be open, which one is closed? It doesn't matter, as long as one's open and one's closed in this particular graph. Okay, so I'm going to make x greater than 0. I could have just as easily made x less than 0 and then made x greater than or equal to 0. So let's find the equation of that second piece of my line. So pick a point. I'm going to pick a different point this time to show you it doesn't matter which one I use. All right, here my slope, rise is positive, rise and run are both positive, so that's +1. X, that point is 3, 3. So that's x minus 3 plus 3. All right, clean it up. I'm going to get x minus 3 plus 3, which is +x. So the equation of that piece of my... Now this piecewise function has a special name. This V shape tells that this is an absolute value. So absolute value can be written with this notation. So this graph is also known as the absolute value graph. And so that's what we're going to be going into next over the next couple of days, our absolute value graphs. Okay, one more. Let's go backwards one more time. So here's your equation, or here's your picture of your graph, and we've got to supply the equation. All right, notice it's got 3 pieces. So let's get this thing set up. That means we need 3 ifs. If. Let's get our domain restrictions first. I'm going to look at this piece of my graph first. All right, so notice here, this is my break. My discontinuity is that x is equal to 1. So here, open circle, so that means I'm going to have x less than 1 for my first piece. Closed circle for my second piece, so x is equal to 1. And this is going to the right, open circle, so x is greater than 1. All right, let's get the equation for these lines. Here again, I'm going to use that point slope form just so I can practice, because it's going to come into play later on. You might not be able to see your y-intercept from your graph. That's why I want to make sure I go over this. Like I said, this is part of your summer pack and Algebra 1 concept, all that good stuff. All right, what's my slope? Let's pick a point. Let's pick a point on our graph. We need a whole point. So let's use this one. Okay, you don't want to put any fractional points because then we can't read what it is. All right, so my slope is 2. X minus 0 minus 3, because this point is 0, negative 3. So that means that my equation for that first piece of my line is 2x minus 3. All right, second piece. It's a point. So when x is equal to 1, y is equal to 2. So it's the point 1, 2. And then my third piece is a horizontal line at y equals 4. So when x is greater than 1, y is equal to 4. Alright, so there's the equation of my piecewise. Like I said, if you have any questions, please jot them down now as you think of them and ask them in class.